Hi, everyone. I guess, as you can see, this talk is called Everyone Knows a Lunar Cycle is 28 Days, or Falsehoods Werewolves Believe About Time. So to set a little bit of context, how did I even get here? A few years ago, I collaborated with Sailor HG, who was at the Zine Fest today, to make an iPhone app. It's a lunar calendar, but specifically a lunar calendar for witches and werewolves. She made a really great website for it. It's cool. She also did the concept, the visual design, managed the freelancers who did the music and wrote the lunar horoscopes. I just wrote the code, and I was like, sweet, I can finally write an app. I can learn Swift. It's going to be great. It's not very complicated. This is the main screen of the app, kind of showing what the phase of the moon is on any given day during a particular month. There's another screen that shows kind of like a detailed view for a single day and tells you the name of the particular moon that's happening on that day. And as you have probably guessed from the title of this talk, writing the code for these screens meant I needed to calculate the phase of the moon on any particular day. So I was doing this several years ago when Swift was really new as a language, and I just wanted to like do something bleeding edge for the fun of it. And there wasn't really an ecosystem, and so I was like, I guess I will try porting some random algorithm for calculating the phase of the moon that I found on the internet using Google. Oh, it doesn't really work for some reason. Maybe I'll try a different algorithm that I found using Google in a different language. Oh, I guess this doesn't really work either. And after the third or fourth attempt to port Python and C and JavaScript into Swift, and the answers from my code never actually being the answers, I was like, this is too hard. Maybe I give up. And then inspiration struck as I read the Wikipedia page about moon phases yet again. Wikipedia said, hey, a sidereal month is exactly 27.321661 days long. And I said, oh, maybe I can just like look up exactly when the new moon was and then repeatedly add 27.321661 days and know when the phases of the moon are. That sounds totally reasonable, right? I mean, it's a float. It won't be perfect. But like, it can't be that bad, can it? It was that bad. Amazingly, though, this actually kind of worked. I coded it up. I kind of like tapped around in the app. I was like, oh, this seems about right. Like I checked a few months forward and backward. The days match. The phases match. Cool. I'm going to ship this to the App Store. I'm super happy that I came up with an answer after many days of not having things work. So 2 years later, this app has sold 3 copies per week. It has like maybe 150 active users. I have not thought about it or looked at it or even opened it myself in like a good 18 months. And Sailor HG gets this very cute, sweet, nice message on Twitter from someone who says something like, I am a practicing Wiccan, and I think your app is the best thing ever, and I love it, and I use it every day, but also, do you think you could make it actually right about when the phases of the moon are? Is there any chance that you could fix that? And I said, wait, what? And so I open the app for myself, and I'm starting to look at that month, and I pull up someone else's moon calendar that I assume is actually correct, and I'm looking at them next to each other, and I'm like, wait a second. So my app was not 1 day and not 2 days, but 3 days wrong about when the phases of the moon should be happening. I knew that the float would be wrong, but I didn't think the float would be 3 days wrong and 18 months wrong. So many hours and a few days of like debugging and what on earth is happening later, I discovered that my entire premise was hilariously wrong. First of all, 27.321661 is the average length of the sidereal month. So at the time, I was like, sidereal, who knows what that means? It sounds astronomical. This is probably what I need. Well, sidereal comes from the Latin word sidera, which means star, and a sidereal month is how long it takes for the moon to end up back in the same place in the sky relative to the stars. It has nothing to do with the visible phase of the moon whatsoever. Oops. So, the phases that we see on the moon are synodic months, and that is the amount of time that it takes for the moon to return to the same position relative to the Earth and the sun. And obviously, the sun is the important part because that is where the light that we are seeing reflected on the moon that makes the phases comes from. Synodic months and sidereal months are different lengths in part, not just because the sun matters, but because the Earth is moving around the sun while the moon moves around the Earth, and then neither of those orbits are circular, they're both elliptic. And you can learn more about how the sun moving, or not the sun moving, but the Earth moving impacts what part of the moon is lit up by the website that Sailor HG made for her Hawaii JS talk 2 weeks ago, which I will give the URL for at the end. So it turns out synodic months, now that we have the right kind of month, they are 29.530587981 days long. So can we swap in that number and now know what the correct phase of the moon is? Unfortunately, not even close. 29.530587981 is the average length of a synodic month. And at that point, I had painfully rediscovered something that I say in another one of my talks that's about metrics. Averages are lie candy for your brain. If we could wait decades or potentially centuries, I'm not exactly sure, individual differences in single synodic months would all average out eventually, and the moon phase predictions would then be accurate, and unfortunately that doesn't help poor Wiccans in the year 2018, or 19 now, as the case may be. But fortunately, in the 2 years that I had been completely ignoring this app, the Swift ecosystem had really matured a lot. And so I just Googled, and the first hit was a GitHub repo that I could copy that would tell me exactly what the phase of the moon was, and that was amazing. So within a few hours, I had just a function call that told me exactly how illuminated the moon was. 0 for a completely illuminated moon, 0.5 for a completely new moon, and then up to 0.99999, and then it loops back around to 0. That's when I discovered the other fatal flaw. So when putting together the visuals for this calendar view, I was like, I don't really want to draw moons myself. Oh, there's this wonderful font called Weather Icons that has beautifully, carefully they're not pixels, they're vectors. Beautifully, carefully crafted vectors that represent good-looking moons. This view, and of course, the Weather Icons font includes 28 slices of the moon, because everyone knows that moon cycles are 28 days long, right? So this view actually includes 27 icons, and you're just going to have to imagine the empty moons before and after these ones. So since I thought that lunar months were always, at the time, 27.321661 days long, I converted lunar cycles into icons that I had by bucketing, as one does when one has floating points. So I would take the percentage of the moon illuminated, multiply it by my 27.321661 number, and then divide by 28. And then I would have an integer that I could index into my array of moon phases with. And as you might guess, if you have done things like this before, this was a total disaster. Individual lunar months can be as short as 28-point-something days and as long as about 30 days. And when you have exactly 28 icons, this just really doesn't go very well. Like, what do you do when 2 or 3 days all index into the same bucket that is the full moon? You're just like, oh, cool, the full moon happened today. Oh, and the full moon happened tomorrow. Oh, and the full moon happened again the day after that. And the Wiccans are like, I don't think that's how that works. So as a calendar to help you plan your life moon events around, it was really a failure, right? Like, here's the rounding problem, right? You're like, oh, cool, 0.61, that definitely rounds to this moon. But 0.638, well, that rounds to this moon. But 0.6, oh, wait, oh no, what's happening? This is not good. No one's really sure. So I literally spent days being like, oh, if I tweak the thresholds, will I magically manage to handle all of the edge cases with different size months? And the answer is no, you will not. So finally, in the end, as I was about to ship the app to the App Store thinking, well, this is better than being 3 days wrong, I realized what I could actually do, and it was calculate the numbers at midnight between each day, and then say, oh, it is the midnight to midnight period that contains exactly 0.5 that will be the one that holds exactly that moon phase. And then I stopped having duplicated full moons and stopped having, like, everything suddenly worked out. Like, no other day would be counted as the day that rounded to 0.5 because nothing would be rounded. So in the end, considering how little code went into this application overall, I feel like I learned an unusually high amount about programming, astronomy, and really bad assumptions that seemed reasonable at the time. And today, Luna's astronomical calculations are accurate to within like a few minutes or hours, which is a really big improvement. Every quarter of the moon falls on the same day as every other lunar calculator that I can find. And it even agrees with other lunar calculators when you ask it about years in the future. It only took me 3 years to get there. So if you want to learn more about Luna the app, you can go to witchy.co. If you want to learn more about how the sun impacts what phase of the moon you see here on Earth and how to use trigonometry to figure that out, you can go to witchy.co/trig. If you want to read my blog post about this disaster, you can go to my blog at andre.arko.net. And if you want to follow either Amy or myself, you can do that on Twitter. Thanks.